For our FRQ for today, we're looking at this graph up above. That's the graph of f, and g is defined as the integral from 1 to x of f of t dt, and we want to find the average rate of change of g from x equals -5 to x equals 5. Average rate of change is always just slope. So this will just be g of 5 minus g of -5 divided by 5 minus -5. So g of 5 is actually the integral from 1 to 5 of f of t dt, and g of -5 is the integral from 1 to -5 of f of t dt. And this will all be divided by 10. Write it one more time. The integral from 1 to 5 of f of t dt minus, well, instead of 1 to -5, you can't really calculate that very easily, or rather you can't find the value with the graph very easily. I'm going to make it minus negative the integral from -5 to 1 of f of t dt all over 10. So we're really finding the integral from 1 to 5 of f of t dt minus a negative turns to plus the integral from -5 to 1 of f of t dt over 10. I have no idea what the equation for f is, or if there really is one. It looks like it would definitely have to be piecewise, but I have the graph and I can find areas. So if we look here, the integral from 1 to 5 of f of t dt, so we start here, go to here. So first we have a triangle. And for this triangle, the area is 1/2 times our base of 2 times our height of 4 plus we also have this rectangle, and the area of this rectangle is 2 times 4. So the value of that integral then is, well, 1/2 times 2 is 1 times 4 is 4 plus 2 times 4 is 8. So the value of that integral is 12. Okay, let's leave that for now. Let's do the integral from -5 to 1. I'll switch colors just because, I can. So -5, so we'll start here. We'll go to here. So let's see, let's start with this triangle. Isn't it lovely? So the area, well, this is under the x-axis, so it's going to be negative. So we have -1/2 times our base of 3 times our height of 4 plus we have 1/4 of a circle. We were told it's 1/4 of a circle. We couldn't necessarily assume that. Is right here. It's below the x-axis, so again it's going to be negative. So we have -pi times 2 squared. So radius was 2, but it's not a whole circle. It's 1/4 times 1/4 plus, and then we have this itty-bitty triangle. And so it's not that itty-bitty, but smaller than other triangles. Again, below the x-axis, so it's -1/2 times a base of 1 times a height of 2. So we end up with -1/2 times 3 times 4 is -6. -pi times 2 squared times 1/4. Well, 2 squared is 4 times 1/4 is 1, so it's -pi. 2 times 1 times 1/2 is 1, so -1. So we end up with -7 minus pi. So now, since we know the integral from 1 to 5, switch the colors again, this integral here, well, that was actually 12, plus this integral here was -7 minus pi, all over 10. The average rate of change of g from -5 to 5 is equal to 5 minus pi over 10. Part B, now we want instantaneous rate of change with respect to x at x equals 3. Instantaneous rate of change is just the derivative. So we want the derivative of x at 3. Derivative of g at 3, sorry about that. So what is the derivative of g in general? Well, since g of x is this integral, g prime of x will be d dx of the integral from 1 to x of f of t dt. And conveniently, we know that to take the derivative of that integral, you just get to put the x in for f of t and call it good. So g prime of x is actually just f of x. So then g prime of 3 is f of 3. Well, f of 3 is right here, so f of 3 is just 4. So then the instantaneous rate of change of g with respect to x at x equals 3 is 4. Part C, on what open intervals, if any, is the graph of g concave up? All right, concavity has to do with second derivative. So let's go there. We're talking about g again. We already know that g prime of x is f of x from the previous part, from part B. G double prime of x then is f prime of x. So we are looking for when g double prime of x is greater than 0. That's when it'll be concave. That's when g will be concave up, which is true when f prime of x is greater than 0. So that means we're looking for when f of x is increasing. Okay? Because if you look just the f business, f prime is greater than 0 when there's a positive slope of the tangent line or when f of x is increasing. Okay, let's look at this. Looking at our graph, f of x is increasing. We're kind of going uphill, I suppose, right here, which is from -5 to -2. And f of x is also increasing from 1 I apologize, not from 1. It's increasing starting at 0. Goes uphill here, going from 0 to 3. So then we have to justify, so we can say it this way. The graph of g is concave up on -5 to -2 and 0 to 3 because g double prime of x equals f prime of x is positive on those intervals. And there we go, answer and justification. Part D, now we want to find all the x values in the interval -5 to 5, which is all we have of the graphs, that's convenient, at which g has a critical point, and we have to classify each as a local minimum, location of a local minimum, local maximum, or neither, and justify. All right, so critical points occur when the derivative equals 0. We've already established that g prime of x is f of x, so we're essentially looking at when f of x equals 0. That occurs when x equals -2 and when x equals 1. So those are our potential critical points. And we're going to have to test around them to see if the signs change. So let's make a little table. There's our x's, and we'll do g prime of x, which is the same as f of x right here. So we already know that the derivative is 0 at -2 and 1. So let's check between them and on either side. So when x is less than -2, we're looking at this portion of the graph, and all of those values of f are negative. Between -2 and 1, which is this portion of the graph, all the values, all the x, or all the y values, excuse me, the f of x values are negative. When we look at this portion of the graph, to the right of 1, f of x is positive. So looking at this, we know that this is, at x equals 1, there is a relative minimum because it goes from negative to positive. It's like a smile. There's the negative, there's the positive. At x equals -2, this is neither because the signs don't change. So we know a couple things as far as justification. So G has critical points. Oops, need an extra I in there. At x equals -2 and x equals 1 because g prime of x equals f of x equals 0 at those points. So that's all the x values where there are critical points. G has neither a local min nor a local max at x equals 1 because g prime, which is just f, does not change sign. G has a relative min at x equals 1 because g prime equals f changes from negative to positive.